All right, 2.6. 2.6 is on combinations of functions and composite functions. So again, we're going to do some problems from the chapter review on page 325. We're going to look at number 70 first. And it says, find the domain of each function. So f of x equals x squared plus 6x minus 3. All right, so what does it mean by domain? So let's come up here. So domain, well, as I like to put it, it's any x value that will make this function valid. It actually works. So what x values can I plug into f of x so that I get an answer back? So domain, x values that make the function valid. Okay, so really what you should be looking for is any functions that have a denominator or a square root. Denominator, square root. And I can think of some other ones, but for now, for this course, we really focus on, Lisa and 2.6 are the ones with a denominator or a square root. If I look at number 70, well, it's just a function. It doesn't have, it's a polynomial. That's what it basically is, a polynomial. And then I can literally plug in any x, and I'll get an answer back, which means my domain is all real numbers. Or if I do it as an interval, it goes from negative infinity to infinity. I can plug anything I want, and I'll get it back. And that's because all polynomials, all polynomials are continuous. I really have no problems with them at all. Good. So that's number 70. What about number 71? Here I have g of x is equal to 4 divided by x minus 7. All right. So before we talked about the domain consists of x values that make the function valid. Well, here I have a denominator, which means I'm going to have a problem if I end up dividing by 0. My denominator cannot be equal to 0. So when I'm thinking about finding the domain, I'm going to take this denominator and find out where it's 0. So x minus 7 cannot, that's the equal sign with the slash through it, equals 0. So let's solve here. So how do you solve? You add 7 to both sides. And you get x cannot be equal to 7. It can be anything else you want, but it cannot equal 7. So how do you write your domain? You can either say x cannot be equal to 7, but it can be anything else, or you can write it as an interval. So let's think about it. If it was an interval, it can be anything but 7. So let's see. What's the smallest it can be? Negative infinity to what? 7. But you cannot include the 7. Instead, you can't include the 7, which means instead of writing a bracket, you must write a parentheses. U means union. And then, again, you have the 7, and it goes off to infinity. This interval is not the same as saying negative infinity to infinity, because here, 7 is included. Whereas for this one, 7's not included. Remember, a parentheses means do not include. So it goes up to 7 and after 7, but it does not include 7. And that's the domain for number 1, or 71. All right, let's try another one. Let's see if we can bump up the, I don't know, what you want to call it, coolness. Let's bump up the coolness. How about 74? 74. So I have g of x equals the square root of x minus 2 divided by x minus 5. Good. So I have the square root of x minus 2 divided by x minus 5. So we talked about domain, and we know to be the domain, these are x values that make the function valid. But for this problem, number 74, two things can go wrong. First of all, I have a square root, which means I cannot take the square root of negative numbers. Not if I want a real answer. All of my answers are real numbers, therefore I can't take the square root of a negative number, and I cannot divide by 0. So let's do this in steps. Let's first find out what x value. In fact, let's take the denominator and set it not equal to 0 and find what x cannot be equal to. So x minus 5 cannot be equal to 0. Solve for x by adding 5 to both sides. And you end up with x cannot equal 5. Alright, so we know x cannot equal 5. What about the square root? Well, we know x minus 2 has to be what? Greater than or equal to 0. Because I can take the square root of 0. The square root of 0, it is just 0. But anything less than 0, a negative number, I cannot do. So, if you notice here, we had a not equal to, and then we have an inequality. Let's solve the inequality. So I'm going to add 2 to both sides, and I get x is greater than or equal to 2. So x is greater than or equal to 2, but it cannot equal 5. So let's see if we can draw an interval. Let's do our interval for this. What's the smallest x can be? 2. The smallest it can be is 2, but is it a parentheses or a bracket? Am I including 2 or am I not including 2? Well, here's an equal sign, which means I need to include 2. So I'm going to have bracket 2, and then I'm going my way up, right? But wait a minute, I cannot have x equal to 5, which means I got to stop right here at 5, and instead of writing a bracket, I need to write a parentheses. And then I have a union, and then guess what? I open back up my parentheses and I write the 5, just like we did for the 7. It's saying it can be everything up to 5 or after 5, like 4.99999 or 5.0001, but it cannot be 5. Comma, and then what's the highest it can be? Infinity. And remember, with infinities, we always write the parentheses, not a bracket. Okay, so let's recap quickly. The domain means x values that make the function valid. What x can I plug into here and get something back? Well, 70 is a polynomial, and all polynomials are continuous. Therefore, their domain is all real numbers. 71, the problem was my denominator, x minus 7. I cannot divide by 0. So if I plug 7 into my denominator, I will end up with a 0, which is not possible. Therefore, 7 cannot be inside my domain. And you do that by saying x minus 7 cannot equal 0, solve for x, and then write out your interval. Don't forget to write the u, because I have two pieces really. Negative infinity to 7, negative infinity to 7, union 7 to infinity. So that means everything except for 7, basically. And then 74, we had a square root as well as a denominator, and we had to work them both. My denominator cannot equal 0, and the inside or the argument of my square root has to be greater than or equal to 0. I solve for x, and again I write out my interval. Alright, so 2.6, we still we have composite functions as well. So let us work on one of those problems from the Chapter 2 review. This problem is number 81 and is found on page 326. So number 81. And the instructions say find, matter of fact, let me write down the function. So f of x is equal to x plus 1 divided by x minus 2. And then they also told me g of x is equal to 1 over x. And it says find f of g, or fog, which is really f of g of x. Awesome. So with composite functions like fog, and matter of fact, we're going to do the other one too. Let's do golf, just for the heck of it. Golf is g of f. Let's start with fog. So with fog, it's saying f of g of f. So everywhere I see an x in f, I have to plug in g. Because notice here, what's inside, because normally we see this as f of something. Well, what's the something that's inside of here? It's usually supposed to be an x, right? So let's look up here. This one says f of x. But instead of an x, what's actually inside of there? G of x. So everywhere you see an x in f of x, you're going to put g of f in there. So let's start up here. So this is f of g of x, or fog, which is the same as saying f of what? Well, what's g of x? It's 1 over x. So everywhere you see an x, you're going to put 1 over x. So let's see. This is 1 over x plus 1 divided by 1 over x minus 2. And let's clean it up because we can. So let's see, this is a fraction. We can make this a fraction by putting it over 1. Here's another fraction. Put this over 1. How do you put fractions together? You have to have a common denominator. My common denominator is going to be x. So my top is going to be, x is my denominator. So I'm going to have 1 plus x. And let me go over that just in case you don't see it. Blue. My denominator is going to be x. Well, I don't have to do anything to this x because he's already x. But this 1, I have to do something to it. So I'm going to multiply it by x, which means I got to do the same to the top. So I end up with 1 plus 1 times x, which is just x, over x. That's the numerator. What about the denominator? My least common denominator is still going to be x. So this x is fine. So I still got that 1. I have that minus sign, but what do I got to change? What do I got to do to this 1? I got to multiply it by x, which means I got to do the same thing to the 2. So I get 1 minus 2x. Good. So awesome. Now, we know the rule. We do not divide fractions. We multiply by the reciprocal. So I have 1 plus x divided by x times now. I need to flip this, so I end up with x over 1 minus 2x. The x's cancel. And I'm left with 1 plus x divided by 1 minus 2x. Good. Now let us work on golf while we're at it. Let me change my pen color. Let's go back to red. Alright, so golf, which is g of f. So g of f of x. So g usually has an x in there, right? G of x. But this one says g of f of x. And what is f of x? It's literally x plus 1 divided by x minus 2. So everywhere we see an x inside of g, we're going to plug in x plus 1 divided by x minus 2. And we end up with 1 divided by x plus 1 divided by x minus 2. Awesome. So I have a fraction within a fraction. And again, we don't do that. So let's fix this up. So this is the same as saying 1. I'm going to actually write it as a divide sign first. This thing right here means divide. 1 divided by what? X plus 1 divided by x minus 2. Now, we do not divide fractions. We multiply by the reciprocal. So we're going to say 1 times, well, what's the reciprocal of this? X minus 2 divided by x plus 1. So my final answer is x minus 2 divided by x plus 1. This is golf, and this one happened to be fog. What do you notice? They're not equal. They do not have to be equal.